How's it going?
Good.
Cool. Thank you guys so much for joining us. Where are you joining us from?
I'm from Berkeley, so joining from the East Bay, California.
I'm in Oakland, so right by Berkeley.
Nice. I'm in Washington, D.C., and we got flooded with the smoke this past week, but I feel like you guys are probably used to that, sadly.
Yeah, sadly.
We got lucky this year. This year wasn't too bad, but yeah, a couple of years ago it was pretty painful.
Yeah, man. Hopefully it is not the new norm, but who knows what the future holds. Well, on a brighter note, I will give you guys the floor, and thanks so much for joining us.
Thank you for having us. So thank you for joining in. Hi, I'm Joey Gonzalez. I'm joined here with Vikram Sreekanti, and today I want to talk about the stuff we're doing with LLMs and what it really means for the rest of us. So let me start with a bit of introduction. So as I said, I'm Joey Gonzalez. I'm a professor at UC Berkeley. I'm one of the co-directors of the UC Berkeley RISE and Sky Computing Labs. I'm a co-founder and VP of product at Aqueduct. So I've been doing research for a long time at the intersection of machine learning and systems. I've worked on parts of Apache Spark. I built GraphX, did a lot of work in computer vision, natural language processing. I did a lot of the early work in distributed training systems, and then some of the kind of seminal work in prediction serving systems. And then I've also been doing a fair amount of work in autonomous driving and robotics. So I do a lot of work in the whole space of machine learning and machine learning systems. And I'm joined by Vikram, who is one of my former students and now my boss and CEO at Aqueduct. And Vikram's work has been studying how to simplify cloud infrastructure. And he's been building on cutting-edge serverless technology with applications in distributed computing, databases, and machine learning. And at Aqueduct, he's really focused on how to commercialize this cutting-edge research. So I come here wearing two hats. I don't have the hats on me right now, but my hat of the Berkeley perspective, where I get to see where LLMs are headed, kind of the cutting-edge research, and then from my Aqueduct perspective, what it means for everyone, thinking about kind of how these LLMs are being incorporated in products today. And so in today's talk, I want to kind of combine these two perspectives and say what they mean for the field. So starting from the Berkeley perspective, at Berkeley, I'm lucky to be part of a leading academic research center on generative AI. We've built some of the core technology behind everything from ChatGPT to Stable Diffusion, the reinforcement learning, the algorithms, even the underlying systems are being developed by colleagues and my group at Berkeley. So there are a lot of innovation across the model architectures, evaluation techniques, inference optimization, distributed training techniques. And I'll try to highlight a few of those in my talk today. One of the things that's important to keep in mind is that at Berkeley, our goal is to push boundaries on what's possible, to think about the next set of problems that people face, sort of the 1% problems, the frontier of technology. Well, Aqueduct is a little different. At Aqueduct, our goal is to really understand what is happening today, what's easy, what's hard, what's missing, what do people need to do to make LLMs real now? And this is really driven by real world use cases, talking to ML practitioners, understanding their challenges, limitations they face with basic machine learning all the way to LLM technology. So our goal at Aqueduct is to enable every software team to be able to build LLM-powered applications. So those are my two hats. And I've been doing this for a while, and I have to say, for the first time, these two trajectories are colliding. What we're doing in research is, supposed to be the distant future, is, affecting what happens kind of next week, and we're seeing this intersection, and LLMs have kind of supercharged this interaction. So I want to highlight that. I'm going to start with the perspective from Berkeley. So I said, Berkeley is an innovation center for LLMs. So I'm going to actually now just focus on some of the stuff in my group. So we're doing a lot in this design of systems, both for training and serving these models. For a couple of years now, we've been thinking about how to make it easier for anyone to train very large models using whole clusters of GPUs. We have a whole set of projects around compilers, optimization techniques as part of the bigger ALPA effort. And we've been transitioning that technology not just for training large models, but now fine-tuning and serving them. We've been also thinking a lot about how we use memory more intelligently to be able to take these models and put them on edge devices, be able to train them on edge devices, and then also even in the cloud to make them 10x, 30x faster by being more intelligent about how we use memory. So building on these technologies, we've also been thinking a lot about what that means for the models themselves. And my group launched an effort to build what is now, I guess today, one of the best open LLMs, the Vicuña model. And as part of that effort, we started to rethink how we benchmark LLMs. And so I thought for today's talk, it'd actually be more fun to discuss what's happening on the right here, what's going on in the space of open LLMs and the kind of implications they have on where industry is headed. So we have to go way back to the beginning of 2023. The foundation model on which a lot of the recent open work in my group and others in academia is built on this llama model. And this is a second iteration of one of the big models developed by Meta. One of the innovations in this llama model that really made it a turning point for research is it's actually built on much better data than some of the earlier foundation models, trained better. And in fact, smaller models trained better on better data results in significantly better performance than the much larger models that preceded it. Now, the problem with the llama model is it's not very good at instruction following. It just kind of finishes the sentence. And so I have some colleagues at another university in the South Bay. In fact, so my former advisor have been playing around with how to take that llama model and actually make it follow instructions, chat like a human, like ChatGPT would, to be more human aligned. And they developed these techniques using self-instruct to create an instruction data set to fine-tune the llama model. And they produced the alpaca model, which was a pretty big step forward. It was an open model that we in the research community could start to evaluate these conversational AIs. But it was developed at Stanford, and we're at Berkeley, and we can do better. And if we refer back to this underlying truth in the design of AI broadly, and then critically of LLMs as well, is it's really all about the data. And there's a better source of data that we can build a better model on. And that source of data is ShareGPT. It's a website that aggregates people's entertaining, fun, hilarious, insightful conversations with AI technology like ChatGPT. And this website is good because these are really high quality conversations, multi-round conversations that people found engaging enough that they wanted to share with someone else. So these are essentially hand annotated 70,000 conversations we're able to pull from the website before the APIs, the public APIs were turned off. And so there's about 800 megabytes. It's not large by large language model standards, actually a tiny amount of data, but it's really high quality data. So with the Vicuña project, our first key innovation was to download this data and remove HTML tags, which is kind of embarrassing, but the reality is that was enough to get a really high quality data set. We then basically followed what our colleagues in the South Bay had done at Stanford to fine tune the llama model. And then we did something a little different because we had a model that we believed was better instruction following, and most NLP benchmarks don't really capture that. We created a new benchmark using GPT-4 to evaluate these models. And so the idea here is that we would give give this model and other models open-ended questions like compose an engaging travel blog post about a recent trip to Hawaii, highlight cultural experiences and must-see attractions. And something like Alpaca goes, I've composed a travel blog post about my most recent trip to Hawaii. Whereas Vicuña goes, aloha, fellow travelers. If you're looking for a tropical paradise with a rich cultural and breathtaking scenery, look no further than Hawaii. So we have these two different responses, and then we asked GPT-4 to be the judge, assess them on engagingness, insightfulness, factfulness. And we actually scored on multiple criteria and built a scoring system to rank each of these models. So we did this, and it was pretty exciting. So here's our Vicuña model at 13 billion parameters. Here's my colleagues at Stanford. So we were better than the Stanford model. We were comparable to a model being developed by Google, Bard. And this is GPT-3.5. So we're, the far right model here is arguably one of the state-of-the-art models that's not GPT-4, and we calibrate that at 100%. And so we're getting close to what GPT is able to produce. And this was an open effort done by a few students over a week, with a few $100s to do a fine-tuning training run. So very exciting results for us. Somewhat of an existential crisis for some of our colleagues in big tech. Again, a few students, a couple $100, a 13 billion parameter model, and it's pretty good. Colleagues at another big tech company, spend $10 million on a 540 billion parameter model over several years, and it's also about the same. This blog got a lot of press. I want to first say that it's wrong. They're not the same. Those models can do a lot more, and the people and teams behind them will actually be able to make them do much more. We're already seeing in newer incarnations, a much broader set of applications. But in these basic open-ended tasks, Vicuña was pretty comparable. So this is an exciting step forward. It was also a little concerning for us that, how are we actually that good? Maybe our benchmark is wrong. And so we decided to create a new benchmark, which would use open conversations with humans in the wild. It's a living benchmark where you can go right now to arena.lmsys.org and talk to any pair of AIs chosen at random. And we're adding new AIs as quickly as we can, or as quickly as people will give us GPUs. And then you ask them a question. You can ask them logic questions, coding questions, and then you evaluate the response. And this gives us a really rich signal about how people interpret these models in the wild. So we took these pairwise competitions, we call them battles, and we used the chess rating system, the ELO rating system, to then score each of the models based on all these pairwise battles. And what's kind of neat is we see a similar result. GPT-4 ranks pretty high in that list, And then Claude, a new entrant, ranks just below GPT-4 and just above GPT-3.5. And then here's our model, Vicuña. Our open model is actually doing pretty well. Here's Google's latest model, Palm 2, and it's performing comparably to Vicuña. And then here's kind of the open source models, and down here is the Stanford model. So it's a pretty cool leaderboard. There are some flaws in this approach, and we actually just launched another paper that discussed some of the flaws in this approach. One thing to keep in mind is that Palm, for example, will abstain in weird questions, whereas a lot of these models will give an answer, and humans like an answer, not abstention. And so when we start to think about like how we evaluate these, we need to have a richer benchmark. And so we've just developed a new benchmark that goes much further than what we did in these earlier experiments, based on the data we collected with this arena. So what did we learn from this experience? Well, maybe the first signal, I'll come back to this again, is that things are happening fast. I'd like to tell you, you should stop training LLMs. You should use our LLMs, unless you're my grad students, and you should keep training LLMs. But the rest of the world should just should just use the LLMs that were created. Unfortunately, we're starting to see some signal that you might still need to fine-tune LLMs, taking open source models and extending them. Maybe what I think we're seeing more, and I'm going to come back to one more project, is that the innovation is going to move more and more from the LLMs themselves to how we use the LLMs, how they will drive the apps that we create. And maybe the best example of this is a brand new project from my group, which is thinking about how we use LLMs to solve a problem we have in my lab. And that is grad students need access to GPUs. And we were asking them to use multiple cloud providers and new startups, and they all have different APIs. And so we've been using LLMs to make it so you can say, go launch 4, this is Gorilla, go launch 4 VMs with 8 A100s in US West 1. And then the idea is that we have a fine-tuned LLM that's designed to take these kinds of instructions. It goes and looks at documentation according to the questions you were asked, and then uses that documentation to directly launch these services to make it easier for humans to interact with the cloud. And so this is a big step forward for us because now we can use more compute. And this generated a lot of interest in the public. In fact, before we even had a chance to promote the paper, it landed in our archive and it was getting thousands of stars. And it was just in the top of Hacker News last night. So it's a project that's pretty exciting, and it's really maybe pointing to where the world is heading. And it's heading away from just building these LLMs to really using to solve interesting problems. So what does this really mean for the rest of us? So I can't stress this enough. Things are happening fast. What's happening in academia is transforming what's happening in industry. And it means that we need to start to react more quickly. And my colleague Vikram here has been thinking a lot about what it takes to enable people to react more quickly. So I'm going to hand it over to him.
Thanks, Joey. So what I want to spend the rest of the talk focused on is how Joey and I have been thinking about all this innovation that's happening on the left side of the screen here, the new models, the new tools that are coming out, and how that innovation actually translates into LLM-powered applications for those of us who don't have the opportunity to work at one of the top research institutions out there in the world. We've been talking with a lot of folks who've been building these applications and trying to do some of this ourselves. And as we've been doing this, we found that this translation has something of a missing link. This missing link is the tooling that lives around how you actually take a model, whether it's an open source model or a hosted one, package it up in a way that will connect back to an application and make sure that the application does what you would expect. This is really one of, if not the next critical challenge that we are focused on here, is how we can take these LLMs and build real applications around them. And as Joey said, this space has been evolving really fast. And the good news is that there's a ton of tools, open source, especially tools, that have been popping up in the last 5-6 months that help us make this transition more easily. So as we've been thinking about this missing link, we've started to notice some patterns in the pitfalls, the traps that people fall into as they're building these applications. The first one, the most obvious one, is probably building or running your own model. Emmanuel, who's another speaker at the conference here, had this tweet the other day that I really appreciated. His old advice used to be to always start with the simplest model, but now his new advice is start with the largest model you can easily try. And those last two words are doing, I think, a lot of work here. The models that you can easily try are most often the hosted models. Of course, in healthcare or finance or some more sensitive industries, you're going to not necessarily be able to use these models in production. But to get started, to prove that you can build an application that, again, takes the innovation happening in research and applies it into an industry application, the place to start is probably by picking a hosted model, maybe using Hugging Face as an API for some of the open source models. Once you have a model, the next pitfall is really around data. Not using any data, trying to construct a very clever prompt that encodes a bunch of information but turns out to be very brittle, or on the flip side, using the wrong data, oftentimes stuffing all of your data into a prompt, which can both be very expensive and can also lead to some kind of jumbled up answers at the end of it. The solution here is perhaps obvious to many of you. It's to pick up one of the many very powerful vector databases that have popped up recently, and to use them to retrieve the right data at the right time, contextualize your prompts, and get better answers. Once you have the code and the data, the next challenge comes around how you actually build these applications, chaining together prompts, experimenting with different models, different techniques. And at this point, you all are probably yelling the answer at your screens. I think everyone here is probably familiar with tools like LangChain and Llama Index that allow you to chain together multiple prompts, try out different models, different techniques, plug things in, and experiment very quickly. Now, all of this is probably very familiar to most of the folks here, but something that we found in our conversations is that the space of people who are interested in LLMs is growing really, really fast. And there's always new engineers, new people coming in trying to build these applications and running into many of the same challenges, not knowing necessarily where to start with the tools. But even for the initiated, the folks who know a lot about LLMs, we started to notice some trends in the kind of things that the kind of pitfalls that these folks are running into. And one that's perhaps a little counterintuitive is relying on the model to do everything that you need. These models are obviously very powerful. They can process very complex pieces of information, generate really interesting answers. But at the end of the day, to use these models, just like with any machine learning model, you're going to want to take some code that retrieves some data from an API, cleans it, featureizes it, passes it into the model, takes the result, validates it, just little bits of code that live around the model itself. And at least now, today, most of the time, this just looks like Python functions that live around your model invocations. Now, at this point, we can put a box around this, and we can call this roughly the ideal LLM stack. The tools here allow you to build a prototype, put together an application that proves a point on real data with real LLM invocations. But the next pitfall, maybe the most painful one here, is actually forgetting about everything else that comes after this. What do I mean by everything else? Well, the list is probably pretty long, but I have a few examples here. The first one is cloud infrastructure management, thinking about where all of these systems run, where does your code run, how does it link up with the rest of the application that you have, essentially connecting the wires so that this LLM-powered application you built can connect back to your team's application or your company's product. Once you have it running, you have to think about the data that's coming into it, not just how you process the data and put it into a vector database, but how you get access to the right systems at the right time, have the right ACL support so that you're not leaking data unintentionally, and kind of just have general governance around what the model is doing. After that, your application's running, and you want to make sure that you're tracking what's happening, the inputs and the outputs, in case something goes wrong or you get a complaint, you actually have the telemetry and the data that you need to debug. And then maybe most painfully, at least for me, there's things like budgeting and cost management, where you can run up very large bills with many of these hosted APIs, or even running your own open source model very quickly. And so having a sense of how much money you're spending, what's actually happening under the hood, and whether you're kind of staying in balance. Like I said, this list is not meant to be comprehensive. There's probably a ton of other things that are supporting pieces of functionality infrastructure that's required to make these applications real. But these are some of the things that Joey and I have been thinking about and have heard from the folks that we've been talking to in this space. And so that's really influenced our thinking. And looking ahead, we're really focused on what's required to enable that next generation of applications. We only have a couple minutes left, so we'll leave you with a couple hypotheses that we've been forming that have influenced how we're approaching this problem. The first one, which is probably uncontroversial to everyone here, which is that the pace of innovation is incredible at every layer of this stack. The models themselves, the supporting infrastructure like the databases, the Python libraries, the number of incredibly smart people who are focused on every one of these problems is a little mind-boggling. And there's going to constantly be new stuff coming out at every layer of this stack. As a result of that, the cutting edge technology here is being adopted faster than ever by top teams. Joey mentioned this earlier about how the gap between what's happening in research and in academia is smaller than ever. And that plays out when you see that people are taking models like Vicuña that are just a couple months old, or even when they were a couple days old, and really starting to experiment and build applications. And combining both of those, the last hypothesis is that teams are going to need the infrastructure, all of these surrounding components, these boxes in blue. They're going to pick the tools that allow them to move fast and keep up with the times. We don't really have the space for opinionated infrastructure anymore. You can't really be in a place where you can say, hey, I support this tool, but not that tool. There's going to be so much going on in the space that we're going to need to keep up, both from an infrastructure and from an application perspective. So the goal here is really to start a conversation around some of these hypotheses and what this infrastructure looks like. If you are interested in the applications here, or you're building some yourselves, would absolutely love to connect. Please reach out at any of the communication media here. And thank you all for taking the time to listen.
I feel like because it's not an in-person conference, you don't get like the massive applause. So it's just me. Here I am. We have a few
counts just as much.
Thank you. We had one question actually. Jay, thanks so much. And also Jay, you should message me after because we'll send you some swag. From Jay, he asked how to reduce latency associated with any hosted models. And can you suggest a strategy to increase context length of LLMs?
Yeah, I can talk a lot about that. So a lot of our research and prediction serving has been around how to reduce latency. It's often an interesting trade-off. We've been looking at how to play with different memory bandwidth tricks to improve throughput, allow for better batching. Often it doesn't actually increase latency, but it gets better hardware utilization. It doesn't decrease latency, but gets better hardware utilization. We've been looking at a lot of work in quantization to get better memory bandwidth, which could translate to reductions in latency. On the topic of context, there's some really cool new research from, again, colleagues at Stanford and other places about how to deal with these larger contexts. It's still pretty new, and it's unclear if it's going to translate to models that could be used in practice. What I've seen as a better solution for people thinking about context is to really focus on retrieval methods and being more intelligent about what context you provide. In part because models get distracted. So you stuff too much in the context, that's often actually a bad sign.
That's awesome. And maybe we can do one more from Aaron Hoffman. Do you see any other languages than Python becoming relevant in the near future?
It's a great question. And I think the short answer is yes, absolutely. One of the cool things about just the explosion of interest in LLMs is that I think it's attracted a much broader audience of people than were previously interested in, the old world of machine learning. And, if you just kind of Google around or go on GitHub, you'll see that people have built the equivalents of things like LangChain in languages like Go or Rust, or even, LangChain itself, I think, has JavaScript, TypeScript bindings. And I think we're going to see a lot of this stuff is going to really expand in scope. And we're going to start with Python because machine learning has historically been done in Python, at least for the last 10 years. But I think absolutely you're going to want to see bindings in other languages and really allowing people to kind of more deeply connect LLMs back to the application stacks that they're building.
Definitely.
Awesome. Thank you guys so much. We'll definitely head over to the chat. I think people might have some other questions, but unfortunately we are going to have to kick you out for the next folks on the agenda. Thank you so much.
Thanks for having us.
Yeah,
Bye.
bye.